The water that covers most of Earth is a mysterious place, home to undiscovered species, shipwrecks from centuries past, and many secrets about how our planet functions. Until recently, exploration beneath the surface was only possible with expensive equipment that kept the curious everyday explorer from uncovering the secrets that lie beneath. Enter OpenROV, an open-source underwater robotics platform that allows the layman to explore the depths for a low cost. OpenROV has opened the market up to people from all walks of life, but there are still some features left to be desired. In any form of exploration, the location of discoveries is a necessary piece of the puzzle, and the OpenROV platform currently lacks this. That's why our project focuses on triangulating the OpenROV, so enthusiasts will know where their rover is at all times. Our method of triangulation uses acoustic waves and an algorithm called time difference of arrival to determine the location of the ROV. In summary, 3 transducers mounted on a surface vessel will send out signals to the OpenROV. The receiver on board the OpenROV will receive these signals and pass them on to the Nucleo board. Then, the onboard Nucleo will process these signals and calculate the difference in time at which each signal arrived. Lastly, this time difference data is transmitted to a computer on board the surface vessel, where TDOA algorithm is run to accurately determine the 3D location of the ROV with respect to the pilot. For this quarter's project, we focused on the signal processing portion of this larger project, namely taking the received signal from the receiver on board the ROV and processing it to calculate the time difference. We will take a deeper look into how this system works and describe what we've completed over the quarter. First, the ADC processes the signal from the receiver, converting it from an analog signal to a digital one. This is necessary because the Nucleo board can only process digital signals. Next, the digital signal is passed on to the digital signal processing portion of the algorithm, in which a finite impulse response, also known as FIR, filter is applied, to separate the 3 signals with varying frequencies. We optimized the filter parameters as well as the parameters used to generate the signal so that we could reduce the overall error of the system. After the 3 signals pass the FIR filter stage, they are smoothed and further processed to estimate the time difference of arrival of each signal. Over the quarter, we were able to complete the ADC implementation as well as the processing of a signal to calculate the time difference, but we were unable to complete the interface between the 2 pieces due to time constraints. Next, we will demo what we completed over the quarter. First, we will do an ADC demo, where we will see 2 Nucleo boards connected, one acting as a transmitter and the other as a receiver. To test our ADC code, we transmitted a sine wave and captured that signal with the second Nucleo board. You can see the converted signal on the screen. Next, we will show a demo of our filter. Here, the filter is shown calculating the time difference of arrival of a signal that was hard-coded onto the Nucleo board. This filter would be applied to the ADC output as described before in a final product. Although our work is incomplete in fully calculating the location of the ROV, we plan to continue this project in the summer to get the system fully functional. This will allow OpenROV enthusiasts all around the world the very useful information location data provides. Thank you.